Hello, good afternoon, everyone. I'm Naoya Ozaki, who is an assistant professor of ISTS JAXA. So, sorry, I had a trouble, but it's okay. Okay, so let me start again. Okay, so let me start the ISTS Young Professional Program, Sustainable Space Development Vision in 2040. Okay, so I'm Naoya Ozaki, who is an assistant professor of ISTS JAXA, and then let me start explaining the concept of this ISTS SSDV. Okay, so I'm one of the representative of the organizing committee member of this ISTS Sustainable Development Visions. So the concept of this Sustainable Space Development Vision is like this. So in the previous decade, so space development vision is mainly presented by the government or space agency. And then the industry, university, and those researchers follow the vision presented by the government or space agency. But in this decade or next decade, the more population in the space industry or university space program. That is why the vision is created not only the government or space agency, but also the industry, private company, commercial company, and university. So that is why for the considering the next space development visions to the 2040, we want to have set up the meeting discussion time to interactively discuss the space development visions among these teams. So I think one of the most important keyword of the considering space development vision to the 2040 is sustainability in the space development. So the sustainability in the space development means environmental sustainability, which is like the management of debris. So we try to remove, not creating a lot of debris, and in this kind of sustainability, but also we have to consider the economic sustainability. You know, the current space program is relying on the government fund, and if the government stop funding space program, we have to stop some part of the space program. So in the future, in the 2040, we have to consider the independence from the government fund. So in those sense, I think economic sustainability is also important. So we divide the whole discussion into the six themes written here. One of that is technological innovation. The other is moon, Mars, city, and space resource utilization, and then environmental protection, industry, academia, government collaboration, international collaboration, and raison d'etre of Japan in space development. So we divide the whole idea into these six themes, and then the six themes and six teams, and then each teams include about 6 members, young researchers from various fields, and then discuss the each topic. And then today, we want to present several ideas proposed by these 6 teams. So the activity of this space development vision, including these 5 activities. The one of that is networking. We had several remote networking events between the team members. And also we had the brainstorming using this kind of whiteboard. And then through the result of brainstorming is presented in today's pitch from each team. In this plenary session, we have the pitch from each team, and also we have a panel discussion after that. And then as a result of this panel discussion and pitch, we want to propose something in some way, but it's currently under consideration. Okay, so so this is a team presenter of today's panel discussion, and also some of the organized committee member, and also commentator from some expert. So I want to introduce those experts. So can the expert turn on the video, Nakasuka sensei and Marco-san? Okay, so let me introduce Nakasuka sensei first. So the Professor Shinichi Nakasuka, maybe most of the people who is watching now knows already, but he's graduated from the Graduate School of Engineering, University of Tokyo, and received PhD in 1988. He joined IBM Research during 1988 to 1990, and then has been working for the Department of Aeronautics and Astronautics, University of Tokyo, and now is a full professor there. He's a member of JSA SAIS IAA and the former chairperson of IFAC Aerospace Technical Committee, and currently chairperson of UNISEC Global. He's also the general chair of ISTS, and his major research area includes micro nanosatellite autonomy and intelligence of space system, and novel space systems, and the guidance, navigation, and control of spacecraft. He developed and launched 13 micro-nano picosatellites successfully, including world first CubeSat launched in 2003. He also a member of Space Policy Committee of Japanese government. So, it's we really appreciate you joining this event.
Thank you very much for your kind introduction.
Yeah. Okay, and then I want to introduce Marco-san. Marco Aliberti. Marco Aliberti currently serves as a senior research fellow at European Space Policy Institute, ESPI, in Vienna. And he's also a researcher at the Space Power and Policy Applied Research Consortium at Flinders University, Adelaide. He has over 10 years of experience in the space policy research with a particular focus on international space relations, government, as well as space security and industrial matters. Prior to joining ESPI in October 2012, he conducted research activity on the international research relations of East Asia at Italian think tank, and has experience in the private sector. He has also 5 books published by Springers and more than a dozen of policy papers, conference proceedings, and public report and space policy matters. Really nice to meet you, Marco-san.
Thank you very much. Hello everyone, and gambatte with the pitch.
Yeah, thank you very much. Okay, so then let's start the pitch session first. So we have we organize 6. We have 6 teams, but we divide that teams into 2. Okay, so we have a 3 pitch first, and then 3 panel discussion at the same time. Okay, so the Sajal team Alpha, Beta, Zeta. Can you prepare the presentation? Okay, Saja, I can see your face.
I'm glad.
Yeah, okay. So can you share the screen?
I will share screen, sure. I shared my screen. Is it visible?
Yes, we can see.
Excellent. So I got 6 minutes. So let's go. Thank you very much for organizing this event. My name is Sajat Kishkar from Tokyo Metropolitan University. I had the great pleasure to be with a very international and multidisciplinary team from all of the world, especially with Keiichiro from an American Japanese representative of the companies of aerospace companies in Japan, Jesus Gonzalez from Colombia, London from Tohoku University, and the others who did not sign up for the final presentation. Very charming and with sense of humor. So I move on to the next. Well, of course, the topic of our team was the technological innovations in space, of course. So we had a major question defined by our leader, Naoya-san, Professor Naoya, stating that we have already a great development in space, but it's very costly, and still there are not enough demonstrations for the public. How can we trigger and promote the technological innovation in space? Well, we divided into several sub-questions, starting from why, at the first place, we should go to the space, what kind of technology should be developed more or most, how should we do it, where are we right now, and what is the next step? So first of all, why should we go to the space? It's a very good question. I think the Professor Nakasuka in the first day made a great presentation, not with these pictures, but he clearly explained why you should go to space. Well, basically, there are some opportunities and dangers with asteroids. This is a new trend. Although the danger of asteroid hitting the Earth is very, very small, but it's still a danger. But mining has been a new trend in the space industry. We have also daily usages of space technology, which many people maybe don't know yet. It's GPS, weather, critical observations, communication, etc. We can also find new technologies as space manufacturing, etc., medicine in space, which cannot be done on Earth as well as in space. I think it's my personal and the opinion of many other authors that finding the fourth dimension, we are creatures in the 3-dimension, but it would be nice to look at our existence from the next dimension and maybe find a way to solve many problems in a different way. Finding energy in space, and a very important thing is to find a balance between the population and development. So we had those reasons to go to space. So what kind of technology should we develop to go to space and accomplish those missions? So we have divided everything in 4 basic parts. The first one is the fundamental technologies. We should improve many things, as one of the most important was the propulsion. The very important question about communication. Should we further develop the Gs? We have now 5 of them. Maybe it's necessary or not to have more Gs in our communication. This is a good question also. Should we come back to, or should we develop nuclear propulsion, etc.? Of course, the presence of human in space is a very critical thing. So we should follow some technologies which have been developed for robots for human being, and also some basic research. We have a lot of room to do material, life science, and planetary science to find the unknown of the universe, and all of this needs kind of robust infrastructure in space. How can we develop such technologies in the best way is when we have an ideal dynamic between three stakeholders, which is academia, industry, and space agencies. One of the problems that we found out is that we have bottom-up research in academia. We have always searching for the best market improvement in industry, and we have space agencies which have more top-down research ideas. We thought maybe some kind of idea which is based on end game approach is to find the real needs of the future and break it down to the actual needs. So where are we now? We have a very great. We have a very great. I'm sorry, I'm just turning off my timer. Sorry. So we have a very good. So we are great now. We are doing great things in space, but we should go further. One of the problems is that we don't have the balance mentioned before. An example is with JAXA, which has developed scientifically many technologies, but never applied them in space. And the US could do it. So this gap is somehow being addressed by PANDAX, open innovation of JAXA, which is good. We have a problem with passion. Many young generations prefer K-pop than the space. This is also an issue we found. About nanosatellites, we think that it should be developed further, and it is developing, and Professor Nakasuga is the evidence. But we have also a lot of critics from the public. Those critics are different from first and third world, and we finally got to the answers of those questions. So first of all, in the short term, we should find in all countries a better harmony between the three stakeholders, bring faster and more rapidly the products, and we should attack real problems faster. In the long term, we should have more public engagement and consider them as a fourth stakeholder. We have to also find a way to engage them more from the school to the space activities. The problem of first world and third world are different. We thought that in the first world, we can have more media coverage. In the third world, we can bring more short-term projects to satisfy the people. So the final goal is to create a space ecosystem that continuously invests in technological innovation, driven by both economic and social forces. So I took more time, but yeah, thank you very much for listening.
Okay, thank you very much, Saja. Yeah. Okay, so let's keep discussing the panel discussion. Okay, so yeah, so from Team Beta, can Luciana present?
Yes. Okay, can everybody see my slide?
Yes, we can see.
Okay. So my name is Luciana. Today I'm presenting for my group, Team Beta, Moon, Mars, City, and Space Resource Utilization. So we start our first brainstorming with a very important question. If cities will be built in the Moon or Mars, would you want to move there? And we asked this in our team. 3 people answer yes, other 2 answer no, 4 of us answer maybe. And the people who answer yes, they want to go to the Moon for the adventure, to feel space and see Earth from above. And the ones that said no, they felt first it's necessary to ensure safety and develop an international laws for the jurisdiction of the state. And with the maybe, people felt in between these 2 answers, like they would like to go, but first it's necessary to specify how long are we going? Is it safe? So in order to drive humanity motivation, we found several drivers for such. Now, the private sector and national governments are again investing in space exploration, where among the tech elite, space exploration is like the ultimate status symbol. And furthermore, the availability of additional resources that can be mined from space could potentially expand the capabilities of humans and largely benefit our society. So using these resources and moving high-polluting industries to space could also help reduce the emissions on Earth and lead to finding a cleaner energy sources. Basically, the primary blockers to colonize space could include technology and economic challenge. Also, according to the International Space Exploration Coordination Group, as a reference for the mission scenario, we looked at the roadmap they proposed, and it shows 2030 as the last milestone. Therefore, it's still a long way to 2040. So, with this in mind, we need to ask the following question. What could be feasible for 2040? Humanity has proven its ability to explore the solar system and live permanently on low Earth orbit. However, not self-sustainable, as ISS still partially relies on supplies from Earth. So therefore, the next challenge is to ensure humans can live in another world in a sustainable and independent manner. Given current technologies, the most viable options for human settlements are the Moon or Mars. And even though Mars appears as the best fit to attempt as a self-sustainable settlement, as it has some conditions which are similar to those on Earth, like the similar day length, for example, our group also analyzed the feasibilities on the Moon and compared them. There are many exciting possibilities here, including the fact that there's water ice on the surface of the Moon, and we could use underground lunar lava tubes for crew protection, and it's closer to Earth for fast transportation. So even if we could conclude the Moon is a stage area, are we humans even needed on site on the Moon for running a profitable business? Yet, 2040s are approaching fast in space terms. And there are many elements vital when it comes to building a space colony, such as technical and human limitations, for example. Distance, proportion, and fuel are the current status of spacefaring technology, including propulsion systems, navigations, resources, and storage. All present limitations to the development of human space exploration in the near future. In situ resource utilization is the key technology to free human mankind from being earthbound. Otherwise, it's about $1 million per kilo for Mars itself. And also we have the human limitations, like physical issues. Without the constant gravity, our bones will suffer osteoporosis and the mineral density will fall. And also, there's the psychological issues. How do we fight the low morale, the depression, our sleeping rhythm, and the fatigue? And this brings us to the first question we began our presentation with. Is it important to remember who we're building this for? It's for us. Would you go to the Moon or would you go to Mars? And how is this new sustainable city on Mars or in the Moon will affect the behavior of the crew? According to NASA Human Research Roadmap, it specifies that the most significant risk with human factors on astronauts' performance comes after expending at least 30 days in space. A trip to Mars will take around 3 years to complete. That's why on Earth, we have facilities like MDRS or a station on Antarctica to teach and simulate life on another planet, or in this case, in a very, very remote, extreme environment. So we have to learn from these analog station mistakes to build on space. And I'm showing you this picture because I took these pictures a few years ago when I did an analog simulation in a station in Utah. And this was the only window in the station. I asked myself, why are windows important? And I think the best example is this window. The cupola in the ISS was born as a place where people could go and get away from the claustrophobia. It's examples like this that show us that there is a need for thinking, engineering, and design as a responding to the human condition. Otherwise, we're just confining humans in a largely futureless steel tube. The same way it can be thought of for windows for the future lunar getaway. We need to generate a connection with the exterior. That will be our main connection to Earth. And although an established Mars city could be far target for 2040, I would like to end this presentation showing you one of the visions for Mars 3D printed habitat challenge, proposing a thick but largely translucent protective shell made out of ice, a material that will contribute to the mental well-being of the astronauts and the morale. The day cycle on Mars is similar to the one on Earth, so being transparent gives an astronaut the circadian rhythm too. This window to the exterior celebrates the landscape and the wonder of living on Mars. The core essence of the Mars and the Moon design, city design, is not to repeat the same mistakes that we did on our planet. They hope to start a new design for living on Mars. All things needs to exit plan, and that allows them to be reusable and repurposed. That can hopefully inspire the change on Earth. Thank you.
Okay, yeah, thank you very much, Luciana. Okay, let's keep discussing in the panel discussion. So next presenter is from Team Beta. Not Team Beta, sorry, Team Zeta, sorry. Muro, can you start your presentation?
Sorry. Yes. Oh, wait a sec. Can you see my presentation?
Yes, we can see.
And more importantly, nobody can see my manuscript, right?
Yeah, we cannot see.
Okay, I start my presentation. So, hello everyone. We are Team Zeta, rising data rail of Japan in space development. So let me start to introduce our team members. So as you can see, most members are Japanese, but their background is various, from academia, startups, government. And also Mark-san gave us a great insight from the foreigner perspectives. So now I explain about the background of our team. The number of countries who is entering space exploration has been growing. By 2040, more and more countries will participate in LEO space activities, including commercialization of space station and satellite constellations. And moreover, some advanced space countries may build colonies on lunar surface and even reach to Mars and other planets. So in those circumstances, how will Japan be able to demonstrate its value? We had serious discussions over this issue, how we can take advantage of our strong points to harness our potential abilities. So our major question is, in such a world, how should Japan demonstrate its value by taking the advantage that differentiate it from other countries? To consider this question, we set 3 sub-questions. So one is what are current strong points, and second is what are current weak points. And for weak points, what we should develop. So what are current strong points of Japan? So we believe that we have mainly 3 strong points: technology, geological thing, and culture. As for the technology, we have domestic capacity to build reliable spacecraft, including launching vehicles like X-A, X-B, and in the future X3, and satellites, and so on. Also, we have a bunch of collaborate with US, Europe missions. And second, we have advantages in the geological things. Our country faces Pacific Ocean, east and south. Moreover, Japan is trusted by many countries as a safe country. In the last, our culture is very attractive. We have a lot of space manga and anime such as Gundam or Space Brothers. They always give passion for space to many people. Next, on the contrary, our weak point is mainly about resources. So, for example, Japanese space budget is 1/10 compared to US budget. To make matters worse, the number of PhD students have been decreasing from 2000. So we concluded that this situation is from the less communication each other. Less communication among academics, industries, and politics. In US, space industry is one of the economic pillars, but in Japan, it is thought as a dream, just a dream rather than realistic economic measures from general people. So to overcome these weak points, academics, industry, and politics all need to make an effort. For example, Japanese rocket is needed to be more cost-effective and shown a presence in the world. About raw resources, of course, national budget is more needed, but academics have to do more outreach activity or enlightenment activities to let people know the real space situation. Or maybe lobbying activity to politics is also needed. So now we don't have a lot of time, so let's conclude our presentation. So to demonstrate Japan's values, our high technology, theoretical things, and unique culture are our strong points. However, of course, we have to overcome our weak point mentioned earlier with concrete actions. So we consider expanding space community, education, and transmission capacity are important actions in the future. So I finished my presentation. Thank you.
Okay, thank you very much, Muro. Okay, so let's move on to the panel discussion. So can the presenters and our commentator turn on the camera? And then I want to pass the mic to Shion.
Okay, thank you, everyone. I'm Shion Ando. Okay, let's move to the panel discussion. Okay, so Team Alpha, Beta, and Zeta talked about tech innovation, space resource utilization, the value of Japan in space development, respectively. Every talk is very interesting. So, okay, so the first question is for ice breaking. Yeah. So, as you know, the space technology is one of the integral of the various kinds of technology. So, in the future, it becomes more important to use various kinds of technology cultivated in other areas. So this is the first question. Which technology do you think in the near future contribute to the innovation of space technology? This is the first question. Okay, so and then please answer first, Saja.
So you told me that the question would be easy, but could you please repeat it? I couldn't.
Yeah. So which technology can contribute to the space innovation of space technology? Yeah. Every answer is welcome.
So if we talk about the technology which should be using space, we are thinking about propulsion is very important because we are very, very slow. So development in propulsion systems is what we have thought as one of the most important.
Okay.
Thank you.
So transportation and the propulsion system is becoming more important. Okay, thank you. How about Luciana?
Yes, I want to address this question from the perspective of construction. So I think in order to achieve the sustainability that we would like to have on Mars or in the moon, we can contribute with construction systems without the need of bringing anything from Earth. We can use the Martian or the lunar regolith in terms of 3D printing, construction, exploring new materials as the soil basalt without the need of, again, transport it from Earth.
Mm-hmm. Okay, thank you. How about Muro?
Yeah, I want to say same thing with Sasha because I'm a propulsion expert. But I want to say the technology which can be used for outreaching is very important, I think. So Team Alpha and Team Beta said a lot of things, a lot of technological problem we have for space technology. But I think a lot of people will enjoy or join our space industry. So by social media networks, many people will join, and a lot of many people which have a various background will come. Is a very important thing, I think.
Okay, thank you very much. How about the experts, Professor Nakasuka?
Okay, can I give the questions? Okay.
Okay, so which?
Yes. So I witnessed the Apollo landing on the moon in 1969. And also in 1968, I saw the film called the 2001 Space Odyssey. And by seeing such kind of the scene or movie, I expect that the space technology and the space travel will be more advanced into 21st century. But it does not happen. So what is the main cause why it does not happen to each teams? Okay, it's not so difficult questions.
Yeah, thank you. I think Luciana got the answer.
That's a very interesting question, and I read a lot. Well, in the past, when there was the big space race for the moon, and basically Russia and United States were racing to see who will arrive first. And a lot of technology was developed during those years. And there were a lot of ground breaks that happened during that time, but also many fails that there were many people who died in that process. So I think nowadays with all the loss that happened, with also all the wins, that space agencies are trying to have this ground race back in a very slow pace compared to years before, because it wasn't only about the technology, but it was also a political issue. So in that way, in my team, there was a lawyer that actually told us a little bit about how nowadays the international law has to actually be applied a little bit in this area, so we don't make the same mistakes as before. In that way, it slows us a little bit as well, but it becomes more safe now to go to space for everybody, little by little.
So that means that we need the time to go there. And so what will be the key point in order to avoid such kind of the mistake?
You mean don't have any...
Yeah. So maybe, what kind of the activity or some, what kind of the technology or activity will accelerate the human going to the space?
Well, nowadays, the thing that is actually gaining a lot of points in space is because all the tech gurus or the billionaires that are basically investing in this, space technology is becoming like a status. Basically, if you put money on this area, then it's a status that you gain. So right now, money is becoming an economical issue for this, and this is why it's accelerating a lot. Of course, the space agencies are also, but they depend on the government. That's what I mean. The private sector is becoming a very important factor in the space race these days?
Okay, thank you very much. I want to hear the answers from the other groups.
Well, Nakasuga-sensei, I remember that you have mentioned also this problem in the first day, and I asked this question to the panelists, like, why we are sending the millionaires? Because the public is not proving it. So we had a interesting discussion with our team. He is of course, everybody is interested in any space trip, and he was following the live sending of Joe Bezos, I think, to space, and reading the comments in YouTube. Everybody was saying why they are going to space, why they are spending so much money, why you don't help. And after maybe 50 comments, very popular comments, he found like a positive comment. Oh, very well done by the engineering team. So I think it's very important to justify our trips to space, and because the money comes from the government, and usually comes from the government, and as you mentioned, our biggest maybe customer is the government, and the government's money is public money. So we should have the heart of the public. We should justify why we are going to space. Maybe we should. So I was very I have this hope that we can do space mining with a better quality and more clarity, so that the public will be somehow maybe satisfied with the trips of the millionaires. So we say, well, they should go now because it will open the possibility for us to go to space. Also, one of the important things is, I think so the population of world is growing drastically, and we have nowhere to and the resources are somehow finishing. So we have two ways: or we should stop the increasing of population, or we should if we stop this the increase of population, we will have a kind of maybe a recession, economic, and maybe also a technological recession. We won't have any goals to go further. Maybe sending people to space or finding more things in space would be a good way to let the people have many children. At the same time, we'll have a sustainable place to live. Well, I let many questions unanswered, but I hope it will make some.
Okay. Thank you. Sense. How about group Twitter?
Yes, I thought these two groups said everything, but it's in my opinion. So Nakasuka Sensei's question was, in my understanding, why the space technology.
So why the space development has not advanced as expected?
Yeah. So my opinion is because in that time the goal was to go moon. So because so if we set the goal more and more advanced, I think the technology will grow more. So for example, if we set the goal as make a society in moon, once the goal was achieved, I think the technology improvement will be stopped. So we need to set goal and more and more. So it's my opinion.
Okay. Yeah, so maybe the Marco will give some questions.
Yeah, just a quick follow-up. Very interesting presentations. Congratulations, omedetou gozaimasu to all of you. Were very interesting and well presented. So you all discussed basically, and also in the subsequent question that was raised by Nakasuka Sensei, the rationales and motivations, for investing in space, etc. And what was maybe, I think, slightly missing or slightly overlooked is a reflection on basically the role that national power plays in investing in space. So I just wanted to have a quick reflection, 10 seconds of reflection by each team on the relation you see between space and national power, or more simply, whether national power, in your view, in its different forms, hard power, economic power, soft power, is an important driver in space activities, because these I didn't think. And maybe how this also relates to the question made by Nakasuka Sensei, and whether how power competition drives, specific developments.
And Luciana, please go ahead. Ladies first.
Please, Gabriel, give any comments. Yeah, of course.
We can give.
Oh, hello. Let Luciana speak first. Hello, everyone.
Okay. With the national power, you mean the diplomatic, the country.
So basically, it's simply also the question, why do we have a space race? Why do we invest in space? Why do we think, space plays a role in the statecraft? It's just a matter of industry, money, etc., or there is something, that goes beyond, that drives, motivations, for government or also industry, to support national efforts.
Well, it's an instrument of military access. It's the same. That's one of the reasons that, for example, people that are not Americans cannot work at NASA, or they cannot work at SpaceX, for example. I don't know. Nowadays, it's a little bit of a controversy, but on the past, it was always seen as it's like the Air Force. The naval force is space. It's the next frontier. The Space Force name, so it becomes a military theme that it can enhance the power of states across the nation. In that way, the more area you can have, or in the ISTS, the lower Earth orbit, or on Mars or on the moon, in a way you colonize that. In the past years, it has been romanticized that, it's not only US that arrived to the moon, but the whole human has arrived to the moon. It has one side of it that, we all humans arrive to the moon, but on the other side, it still is a race for space, because it's a military aspect in the end. I don't know if Gabriel wants to add something.
Thank you, Luciana. Hello, everyone. This is Gabriele Impresario from Italy. Yes, I agree with you. Of course, space is a strategic sector, and the strategic role that space technology plays is, of course, seen by everyone on Earth. But the most important thing about space, in my opinion at least, is the attraction for the fascination of space itself, and the image that someone who can go actually provide the space program receive projects to the other people, to the other countries in the world. So space is a strategic sector, not only for the technology and tactical point of view, and strategic as well, but also from an image point of view, a status point of view. And this becomes a driver for other players to wish to enter the space sector, and to wish to achieve some results in space technology and space exploration. But please, I would like to answer also the question of Professor Shinichi. I guess that, in my opinion, everything was slowed so much because we studied, we researched, we understood that space was not very easy. Humanity went through a lot of failures that during the space race, but also in the aftermath. So all the space agencies understood that there was a need for testing and to allow the proper time before sending humans on new space systems. We have examples under our eyes. There are some programs that last years before they can actually send humans to low Earth orbit. We are talking about the moon. So, of course, the international scenario now, after the Cold War space race, has changed a bit. There are new players coming in. Dr. Saja earlier mentioned the billionaires. And yes, governments still play their role, and they respond to their taxpayers, and they have to assure safety in flight for humans and also for other assets in space of other countries, and even if they are not crewed. But yes, you are going to see an exciting and virtuous interchange between space agencies, governments, and privates that, of course, need the support of governments and space agencies. Because as I believe Masaya Muhara told earlier, but also Dr. Saja, and the space agencies still drive a lot of funds that help basic research for the benefit of all, while the private sector, of course, while of course trying to address common problems and to resolve common issues. Of course, the private sector tends to go for the profit. So there will always be the need for balance between public benefit and profit of businesses. That's a point, my point at least.
Well, about the power, if I just want to tell it in a very short, maybe it depends on the situation, because in the 60s and 70s, chess was very popular, and the game of Kasparov-Karpov was followed by many people. But now nobody even knows about chess too much. I think it's also about space. There was a time where, for the public, space was the power, but many people in, for example, Mexico, and many people they don't know even Mexico has a satellite. And I know, well, I live in Japan, and I know many people who are passing regular space, but some of them, they don't even know JAXA is a Japanese company. They think that it's American. So I think the public doesn't think that space is power, but of course the government and the scientists, we know that there is a real danger and power in the space industry.
Yeah, I think those discussion is related to the next presentations and also the panel discussion. So yeah, so let's move on to the next pitch and the panel discussion. Can we?
Thank you very much.
Okay. So let's move on to the next pitch and panel discussion of 3 groups. Okay, so the first presentation is from team Gamma. Max, can you present?
Yep, let me set up my screen. Okay, can you see my screen?
Yes, we can see.
Fantastic. Okay, so good afternoon. It is my pleasure to represent Team Gamma, which consists of the following members. So Akiyama Mariko, Izumi Keisuke, Kimura Shunta, Nate Taylor, Paolo Martioli, Roger Gutierrez Ramon, Sugahara Haruna, and Vinicius Neri. My name is Max Berthet, and I'm a PhD student at the University of Tokyo. Together, we've spent the past few weeks working on the topic of space environmental protection, and today we would like to share with you the problem we decided to focus on and our recommendations in this area. We hope you enjoy our presentation. Our team was given the following focus question: facing the acceleration of space activities in geocentric orbits and beyond, how can the global space community preserve the long-term sustainability of space? Faced with this very wide-ranging question, we decided to refine our scope by focusing on a specific time and location. We decided that space sustainability can only be ensured by addressing its long-term dimension, and we decided that at present, the most valuable and at-risk area is near-Earth orbit. So this is where space activities have the greatest impact on life on Earth. We also recognize the importance of sustainability of the space industry in general, as well as of the impacts of space activities on the environment at the Earth's surface and on other celestial bodies, but we decided not to include these topics in our scope. So after selecting our topic, we analyzed the current situation. We concluded that one of the greatest challenges regarding space sustainability is the low availability and dissemination of clear information on this topic. For example, discussions are usually held only among specialists on a technical level. So this means that the general public is not always aware of the problem, and hence politicians and industry don't prioritize regulation or self-regulation in this area. In this presentation, we will explore how to advance this topic to the forefront of more discussions, and we will consider how to improve outreach and whom to engage in the discussion. And we will also share our recommendations on potential methods for this purpose. As a starting point, we produced a map of the major stakeholders involved in efforts for the sustainability of space activities in Earth orbit, and we studied their relations. Based on the map, we identified three main nodes. The first is industry, which has the ability to self-regulate and bring about fast technological change to promote space sustainability. The second is government, which has the authority to guide the focus of industry through regulations and investment. And the third and most important for our purpose is the public, which has the power to foster slow yet long-term behavior changes in industry and government from a bottom-up direction, which is aligned with our target. Behavior changes are critical for the following reasons. Firstly, with satellite launch rates increasing, how, what, and why we launch is critically important. Secondly, equally important is the behavior of space actors regarding post-launch practices. At present, the public is in a pre-contemplation phase, and most space players have few incentives or motivations to prioritize space sustainability. And therefore, based on those observations, we set the following objective: to build up public awareness and engagement with space sustainability, striving for long-term change. In order to achieve this goal, we propose two new recommendations. The first relates to provision of information. We recommend to regularly compile and share relevant information to promote awareness of space sustainability and of the importance of space activities through respected multilateral bodies such as the IADC, Interagency Space Debris Coordination Committee, in an open and collaborative framework by mobilizing and or creating authorities to engage with the public. So in this way, the resulting downward pressure on space industries and governments may promote greater self-regulation. And in addition, the reach of a multilateral body such as the IADC is expected to be valuable to normalize sustainable space practices, as many more nations continue to become spacefaring. Our second complementary recommendation is to ensure the information effectively reaches the public by using diversified channels, including unconventional methods such as podcasts and YouTube, as well as traditional information mediums such as news networks, drawing upon participation from respected institutions like space agencies and individuals, including astronauts. And in particular, we would like to focus on the younger demographic to ensure long-term sustainability. In this way, by cultivating factual, up-to-date education of the younger generation may play a greater role in space sustainability in the same way as it already does in general environmental sustainability, including by developing new technologies. So in conclusion, it is likely that an engaged and educated public will exert downward pressure on industries and governments for more self-regulation in line with existing trends towards environmental consciousness. And in closing our presentation, we would like to end with the following remark. The decisions of organizations are ultimately made up from the decisions of individuals. And therefore, based on our group's discussions, in order to achieve a sustainable space environment, all users across all segments should approach their activities by adopting a role of stewardship towards the space environment. As researchers, as individuals in an organization or as decision makers. So this concludes our presentation, and we would like to thank Naoya Ozaki and Quentin Versperen for supporting our team as facilitators, and we're looking forward to your questions and comments.
Thank you very much, Max. Perfect timing. Yeah. So let's keep discussing in the panel discussion. So let's move on to the next pitch by Ataka, Team Delta. Can you prepare your presentation? Yeah, we can see, but I cannot see, hear your voice. Hello, Ataka. Yeah, I think it trouble of your microphone. Can you try to debug, and then can we start next presentation first during at that moment if the Naoko is ready?
Okay.
Sorry, yeah.
No problem. So
Okay.
let me share my screen.
Yeah, thank you very much.
So can you see it in a full screen?
Yes, we can see appropriately.
Thank you very much for your kind introduction. I'm Naoko, a master's student at the Graduate School of Public Policy, University of Tokyo. And I'd like to speak about our theme, international collaboration. The question of our team is how we should encourage international collaboration for win-win situation in the face of expected technological gaps among different countries. There are mainly three forms of international collaboration. And firstly, cooperation among advanced space powers to achieve higher goals, such as collaboration for ISTS, or manned space flights, or space exploration. Second is advanced to emerging in order to transfer knowledge, which is called capacity building. And thirdly, collaboration between emerging countries to achieve lower levels goals. Of these three, our scope is advanced to emerging capacity building programs, and they are conducted by different types of donors. In existing type of capacity building project, each donor has different motivations. Universities' main purposes are education and research. Private companies prioritize commercial gain, and the state pursue national interests such as diplomacy and trade. And the main purpose of non-profit organization and international organization conduct for education and research. Although international organizations are supposed to provide projects for the needs of recipients, the structure of capacity building makes it more complicated. Therefore, let's look more details. The problem of current capacity building projects by international organizations is that they have been driven by a single country. Looking at the project being conducted under the UN Office for Outer Space Affairs, microgravity experiment is operated by Germany, KiboQ by Japan, Asia Pacific Regional Capacity Building Centers, and the China Space Station by China, and also Payload Hosting Initiative by UAE. In fact, these services are a collection of those by one country, and there is few real international capacity building framework. In order to solve this, we need to strengthen international capacity building frameworks to avoid suspicious and ensure capacity building programs tailored to the need of the recipient countries. Since creating a new international organization would be too complicated, we would like to suggest to rely on existing structure, which is UNOSA, for quicker solution. However, UNOSA has several weak points. Firstly, as I explained before, there is suspicion of purely national motivated programs. Secondly, lack of human resources and funding. Budget and staffs here indicate how it's limited to provide programs only by UNOSA. As a result, they have to rely on single donor countries. And thirdly, because of lack of resources, they cannot manage direct channel with individual groups, such as having local offices. If recipients want to use UNOSA's services, they need to contact through their governments, and it makes it difficult for them to participate in. Therefore, we would like to raise 4 proposals. First, increase funding for UNOSA programs to reduce dependency on conducted national contributions. And we think that multilateral development banks such as World Bank or African Development Bank, and also bilateral donors such as JICA, can be potential sources of funding. Second, increase UNOSA's workforce by encouraging more countries to second officials to support capacity building programs. Third, require each nationally funded capacity building initiative to be supported by at least 2 different countries. And finally, restrict the scope of capacity building to priority and non-contentious areas. For example, rocket launch technology has risk of military diversion or leakage. However, rough remote sensing technology is useful, for instance, disaster monitoring and agriculture. Also, knowledge for administrative management for space activity is helpful. So if international corporations limited to those areas, many countries can benefit from space technology. Thank you for listening.
Okay, yeah, thank you for a wonderful presentation, Naoko. Okay, so I think Ataka is ready for his presentation. So are you here? Okay. Yes, we can see your slide, but I cannot hear your voice.
While Ataka correct the setting, I suggest maybe, because we have a short time, maybe to start discussing a bit with the panel.
I agree.
So how could we stop the screen sharing?
Okay,
yes.
so the commentator and presenter, can you turn on your camera? And then let's start discussing.
Yes, so hello everyone. My name is Quentin Verspiren. I'm an assistant professor of space policy at the University of Tokyo, and I'm glad to be moderating this panel. First of all, I thought that the two presentations, and I'm sure the third one will be the same, were really interesting, very well articulated. So the first one on this really important aspect on ensuring space sustainability by raising public awareness and raising also the public's engagement in the issue that is very much an expert issue in current times. And the second presentation by Naoko, how to bridge the gap, the technological gap between countries by reinforcing one of the forms of capacity building, that is capacity building conducted by international organizations. And I'm sure both experts share my excitement at these two presentations. It was really nice. Marco, would you like to start this time, making a few comments and potentially questions for the two panelists?
Thank you, Quentin. No, indeed, excellent presentation. Also very concrete in terms of outcome and specific recommendations. So I think particularly value-adding from that perspective. You all discuss, different ways, of engaging and doing things in space. And as Naoya-san talked about, we talk about, creating a sort of sustainable space ecosystem, and to do that, but I think also the third presentation will focus on that, to have a more sustainable ecosystem and also to make better use, of the resources we have, because those resources are limited, of course, and we cannot just expand the budget. We need engagement. We need to create synergies and cross-fertilization among different stakeholders. So between the government, academia, the public, the space industry, as well as between the space industry and the non-space industry. So I just wanted to know whether you have some thoughts, on what in concrete we could do, for instance, to foster this engagement, this cross-pollination of ideas between different stakeholders, and also how can we attract, people in the space sector from the non-space sector. Of course, this is a very broad and plethoric question, also maybe challenging, but I'm sure you paid some thoughts on it. Thank you.
So what we will do is I will ask you to give short answers so that we can have several rounds. So starting with Max, then Naoko, and after you give your two answers, let's go back to Ataka to see if she can finally present. So Max, please.
Okay, thank you, Quentin, and thank you, Marco, for the question. So I'll be brief, and I hope I don't mention something Ataka wants to say. So in Japan, as we saw in the previous session, the budget for space activities is quite limited. But on the other hand, the budget for other industrial activities is quite big. For example, Toyota is the biggest company in Japan in terms of budget. So creating partnerships for economic purposes is one option. And Toyota has supported iSpace in the past for their rover project on the moon. So continuing similar activities is one way to bring mutually beneficial returns to both parties.
Naoko?
Thank you for your question. So my opinion is what was in our presentation. So right now each country has their own budget, and so it's kind of US has a lot of budget for space compared with Japanese budget. And it's difficult to engage all public or people in non-space industries. So what I thought was it would be better if we can use other, for example, development banks or JICA, which are now doing other activities in other areas, and now our life space technology is very benefits our life. So I think it will be one solution. Thank you.
Thank you very much. I think these were excellent points. Indeed, space technology impacts every aspect of our life. So all aspects of our society should also consider involving in space and supporting some form of engagement in space. Now let's move to Ataka. I hope it will be fine. We are really eager to hear your presentation. Could you try to share your screen and unmute?
Okay, sorry for the sound and screen error. So hello everyone. Our group is Team Delta, and we discuss about industry and academia government collaboration, and we especially we focused on increasing of the space related workers number. Yes. And so here's background. So this left graph shows the number of the space industry workers per year. So as you can see, recently it increased a little, but compared with the expansion of space technology and space industry, the number of the space worker is not rapidly increasing. So we thought like we need to increase these numbers for sustainable space development. So here is our proposal. So firstly, we should inspire the young generation, and second one is engagement to motivate young people to choose space-related measures for their future careers. And the third one is education. So establish aerospace faculty in several universities and provided scholarships for studying students at space majors, and a more recurrent education. And fourth one is the increase of employment by expanding the space-related fields. And from now on, we talk about each sector's role, each sector's what they should do. So at the academic part, we think like we should need more media coverage because we don't think they don't have enough media coverage currently. So it's very important to inspire young generations to join aerospace faculty. And it will increase the collaborations between laboratory and non-space company. And the second important point is the increase of recurrent education. It will increase the job opportunity for people who don't work at space industry, but actually want to work at space industry. And the third one is the usage to expand the usage of space technology. So it will motivate a non-space company to enter space industry by searching and informing the usage of space technology. And here is the role of industry. So current problem of industry is the less number of the space workers in compared to other developing space country, and also less numbers of the masters and the doctoral graduates who studied aerospace contents, but who actually go to space related company. It's less than 50% in Japan. And also currently, we think that the current education opportunity is not enough for employee in non-space related companies. So and the fluidity, the influx of the people in space industry is also less compared with other industry. So here is our proposal. We want to we should promote further use of the space, and we should establish infrastructure as a space. We should establish space as an infrastructure. Yeah, it will make more employee and establish more how can I say, the farm company. And third one is stability and attractive compensation. Because currently we have less image of human resource fluidity. in Japanese 人材の流動性が、あんまり宇宙産業に見られないっていうのがありますね。And fourth one is, yeah, we should promote more way of the usage of the space. And third one is the role of government. So, yeah, government should promote more anchor tenancy, which means government purchases multi-year products and service from industry to establish a small industry into to change small industry into more bigger industry. For example, the government should take the initiative in purchasing data from the satellite and utilize it for transport service. And yes, this will result more increase of the demand of the space development. And also, government should encourage non-space related industry get into space industry. And the third one is human resource development. So yeah, as other presenter says, the student in doctor course is not enough, and we should increase through inspiration or recurrent education. Yes, and so here is a conclusion slide. So we summarize each sector's role and also each sector's relationship. So yes, that's it. Thank you for listening.
Okay, thank you very much, Ataka. And then let's go back to the panel discussion then. Can the panelists turn on your camera?
Yeah, thank you very much. I think what's great is that it kind of answers your question, Marco. So that's you offered us a great transition to that. So I think now I would like to ask Nakasuka Sensei for feedback.
So I was asked to give common questions to all of the three groups, but it's a really tough questions for me. So please allow me to give a separate questions. Is it okay?
It's okay.
Yeah,
sure.
Yeah. For the first environmental space environment sustainability program, maybe I think not only the new satellite to be launched into the space, but also the old satellite or old launch vehicle which are staying in the space should be retrieved. That is a very big risk to make a lot of small debris. So how or who will pay to remove such kind of the big old debris? That will be a very tough questions. And so maybe that we should solve that question. How do you think about it, Max?
Yeah, that's a difficult question. I wish I had a perfect answer at this stage, but so obviously debris is something that concerns everyone. So it would make sense to create a way for every country to contribute to some way in solving this issue. But at the same time, we have to recognize that until now, the debris has been created by a relatively small number of countries, for example, Russia or US or China or a few others. So we have to think about how each country can maybe contribute in a proportional way to addressing this issue. So in the end, it's going to be about cooperation. So the first wave of space development was driven by competition, but these days we need to shift the engine to cooperation, and that will also be important to solve the debris issue.
Yeah, I understand your answers, but can we persuade them to pay money to retrieve all the debris? How do you think about that?
So if someone else wants to jump in, please feel free. But yeah, in my opinion, there has to be some return somehow. So if they're giving something, they have to receive something in exchange. So the question is, what can they be given in exchange for being more responsible towards the space environment? So there could be some stipends for industry, for example. So if they contribute to reducing space debris, then they could receive some stimulus to pursue other projects. Or they could receive some budget to cooperate with other countries. So that could be another way to solve the problem, and in addition to develop new partnerships.
Okay, I understand. Thank you very much.
May I interrupt and then
please.
Can I actually discuss these things? Yeah, actually, similar things we have discussed in the team data, the raison d'etre of Japanese space program. So then at this moment, we have to say that the launch vehicle of Japan is not that competitive compared to the US commercial launch vehicle. And to answer to that question, maybe if we can recycle the satellite, for example, 10 times, even if the launch cost is the 10 times more, we can do a similar type of mission. So maybe, not just make it the garbage, but if you can recycle, maybe we need a more technological innovation for recycling the satellite, but if you can recycle satellites, many times I think it's more probably beneficial, perhaps. Yeah, that is what I'm thinking.
Yeah, maybe so. Recycling of the satellite would be a very important technology, but that kind of technology can be applied to the satellite from now on. I think it's a little difficult to utilize this technology to the already launched satellite. And so, if the such kind of the already launched satellite can be recycled, that would be very beneficial. So, do you have some idea how to do it?
Yeah, but that is a very difficult question. Yeah, well, actually, yeah, yeah. But obviously, I think we need a lot of more technological innovation for doing this.
Yeah, but thank you very much. And Gabi is raising hand.
Yes, I remember I read a manga about this. It is called Planetes, and it is based in a, let's say, a bit distant future from now. The idea of recycling spent satellites, decommissioned satellites, is something which is very fashionable. But we are now in an era where mankind is starting to recommission satellites. There are examples of satellites that are for in-orbit servicing. They can alter the operational orbits and give some boost to some geostationary satellites. For example, it has already been done. And yes, that could be a far goal for 2040. Starting to recycle the spent and decommissioned satellites or debris. Of course, there is still a way to go. And what we can do now, the action space agency, governments, and also private sector can act now, is to build up a set of standards, internationally recognized standards, that in first place avoid the proliferation of debris in Earth orbit, and second place, of course, it is maybe a way to address this is to start designing spacecraft in order sometimes also to be, let's say, recycled in orbit, which is not something very addressed as for now. Because industrial standards are focused on other aspects. Of course, the regulations regarding the orbiting are starting to be taken seriously. Yeah, short answers. Starts to be taken seriously by everyone in the space sector, and it is very important to avoid overpopulate the Earth orbit with debris.
Thank you very much. So Nakasuke-sensei,
yeah. Thank you very much. I'd like to give a question to the Ataka-san. So maybe I guess the exchange of the personnel between the, for example, government, big company, and the new industry would be very important. And I think in the current, for example, in the current Japanese culture of the business, it's very a little tough because each member, each employees have some loyalty to their company and so on. But I think retired person or something like called the silvered person has a very good capability of the and the experience, and I think they can go to have a small industry and so on. So that kind of the human exchange would be a Japanese way to do the exchange. So how do you think about that?
I completely agree with that. Yes, I think I understand the atmosphere difference between like USA company and Japanese traditional company. So yeah, that's really good idea to obtain silver people for new startup company because they have a lot of technological knowledge.
Yes.
Yeah.
And they are very seems very young in Japan.
Yes.
Including me.
That's what I was going to say. You're talking about yourself, right?
and I'd like to ask to the Naoko-san, final group. And I think we Japan have been supporting the emerging country to develop the first satellite, CubeSat. But important thing is that activity should continue after the first CubeSat. And it's very difficult for the Japan to support the follow-on project and so on. So what would be the most adequate way to support such kind of the country who want to create their own space industry after their first CubeSat? So that would be a very important questions.
Thank you very much for your question. That's a very important point. And when I look at many attempts to create a satellite, and they have some country has program of continuation of the knowledge transformation. So my opinion, one of way to manage it is that to build administrative management system in the country, not only engineering technology, but also non-technological knowledge will be very important for that kind of emerging countries. I hope that answers your question.
Yeah, thank you very much. And it's very similar to your answers, but I think it's very important for the Japanese, for example, for the Japanese people to participate in something like a planning of each country's, space development. Strategic planning should also be, supported by the Japanese government. Then we can do more, dense or deep collaboration with them. So that would be one way. I think that kind of the thing is important in addition to the technological support. So this is my
that's a very good point because you cannot follow up forever. So it's better to give them the ability to be able to develop a long-term strategy. Indeed. We have a few questions on Slido, and considering the time, I will select one of these. So someone is jumping on the proposal from Naoko to use the UNOSA as a hub, and that in the current situation, so most of the capacity building contribution promoted through the UNOSA are actually national contributions. But so in the proposal, Naoko was talking about making it more international. And if I understand correctly, what Shima is asking in the question, it's now countries have a motivation to have nationally motivated project to further their national interests through UNOSA. Would they still be motivated to participate in a purely international framework? And not to ask this question to Naoko specifically, I would like to hear from the others, actually. So let's say, Max, do you have something to say about it?
Yeah, thank you for the question, Quentin. And it depends on whether both countries can gain something from the partnership. So maybe when they begin collaborating, they should have a clear understanding of what they expect to gain from this and what each partner can contribute to the other. And so by starting the relationship in that way, maybe disappointments and illusions can be avoided.
Ataka, anything to say about that?
Sorry, I couldn't catch up. Could you repeat the question?
What would motivate countries to support a purely international capacity building framework? Because their interest is to help directly the country so that it can help their trade or their diplomacy. You don't have to answer if you don't want to answer this question.
Yeah, sorry, I don't want to.
Okay, I think we have 2 minutes, and I think Max had a question for another group. Would you like to?
Yeah, thank you. So I wanted to ask Ataka, you mentioned that one problem in the space industry in Japan is the lack of workforce. But in my experience, it's actually quite difficult to start work in a space company. For example, if you don't have experience, maybe you won't be accepted into that company, especially as an engineer. So how does this problem play into the overall lack of space workforce, and how could this be addressed?
Tough question, but a very important one. Ataka, you're muted.
Yeah. Yeah. Firstly, we should create more. How can I say that? More business chance and create more. How can I say that? Employment opportunity. So yeah, it will expand the window for non-space related workers. But but currently I don't have a concrete solution for this problem.
Okay, I got it. Thank you.
Okay, anyway, we're arriving at the end of this panel. The only thing I would like to add on this is that this is also part of the answer on how to ensure sustainability in developing countries. That it's good to have capacity building, it's good to train people. But if you have a lot of people who go abroad, come back to the country, and they have no space-related job, the space knowledge gets lost. So having opportunities for people who are passionate, who want to learn, is the only way, I mean, one of the only ways to sustain long-term space projects. But we are running out of time, and I need to give the floor back to Naoya. And I would like to thank the two experts, Marco Liberti and Professor Shinichi Nakasuka, for asking very good questions to the groups. Thank you.
Okay, so thank you very much. Thank you for I want to appreciate the all panelists, I mean the presenters, and also expert Professor Nakasuka and also Marco-san to join in this the young professional program. In the end, I want to ask all presenters to turn on your video and then see in the same frame.
Take a picture.
yeah, maybe. Yeah. Okay. Yeah. Okay. I see. So this was the first attempt to doing this kind of discuss. This is the first time to attempt to discussing the common vision among the generation, among the expert, and also the industry, academia, and government, I think we should keep try to doing this kind of discussion for the future to achieve future space vision. So I think we want to discuss these things in the next ISTS or future ISTS, and then to achieve the our final goal. So I want to appreciate the listener and also presenter again, and then let's keep discussing for the next time. Okay, so thank you very much, and have a nice day and week. Enjoy your final.
ISTS will continue until tomorrow, so please enjoy one more day.
Yeah, okay. Thank you very much.
Bye-bye.
Ciao, everybody. Thank you, everybody. Ciao. ありがとうございます。
Thank you. Bye.